Okay, developers, welcome back. In this video, we're going to combine our knowledge from the two previous videos and we're going to create a REST API connected to a DynamoDB database. We're then going to deploy this using the AWS CDK. So we need to learn how to create DynamoDB tables, how to grant database access to our lambdas, and how to pass this configuration data between our database and our REST API. So let's just combine everything and jump straight into it. Okay, in this video, we're going to use DynamoDB. We're going to learn how to get data out of our database. And I think we're going to start with the easiest part, which is usually the lambdas. So inside the lambdas folder, I'm going to create a new folder called products. And we're going to have a file called get_all.js. Before we get started, we need to import some packages. So we're going to do npm i. We're going to import the lib DynamoDB. We're also going to import the client DynamoDB. So we're going to run that, maybe if I spell things correctly, npm -i, and we should be good to go. Okay, we're going to start off with the get all lambda. So we're going to create module.exports.handler. It's going to be async. It's going to have the event and the context. But first we need to actually create DynamoDB variables. So we're going to have const DynamoDB client. That's going to be new DynamoDB. Don't spell it correctly, but let IntelliSense figure it out. There we go. Now we need to have DynamoDB, and that's going to be DynamoDB client, the document client, .from, and then add our client in there. So now we're able to create a try catch. Inside the try, we're going to have a database response. So I say DB response, and that's going to be await DynamoDB.send. What are we sending? A new scan command, which comes from the client DynamoDB. Now inside our scan command, this is going to scan the entire database. This is not recommended if your database is large. Really, we want to query stuff that is cheaper than scan. Scan will go through the entire database. We don't really want to do that very often. But the scan command needs a table name. We haven't created that yet, so we are going to, at some point, inject the table name into this handler via environment variables. So we're going to have the, let's call it product table name. That's going to be process.env. Let's call it product table. And then when we scan our table, it's going to be the product table name. From there, we can return a response, status code 200, and the body is going to be JSON stringify. We're going to have DB response. And then when you get the data from a database in DynamoDB, it comes back as items. To close that, make some more space. So our response is going to have items, and we're going to JSON stringify the items. Tiny bit of error handling. So we're going to have return status code error body JSON stringify, and we're going to return the error. So this is a simple handler. It's going to scan our DynamoDB table for all the items, which is not recommended for large data sets, but for now we can do this. But it also needs to know which table it's scanning. So in a few minutes, we're going to inject the actual table name that we want to scan. Now this handler is done. It returns our items from the DB response. So let's do another function to get a single item. This one gets all of the items. Now let's do a single one. So inside the product folder, and create a new file, call that get1.js. And again, we're going to module exports.handler. That's going to be async, event and context. Let's force a habit. Again, we need to get access to DynamoDB. So we're going to have DynamoDB client. And again, that's going to be new DynamoDB. And with that client, we're going to pass it into DynamoDB. So that's going to be Dynamo document client .from, and then pass in our client there. So now we can use scan and query again. Now this handler is going to take in a product ID. So if we have our URL, let's say blah, 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 .com, and then we're going to have products and then 001. So this 001 is what we need to get off of the event that is passed in. So we're going to have product ID, and that is going to be event.path parameters. Can I spell this correctly first time? And then product ID. Now we'll set up this resource in a minute once we create our REST API. But for now, we know that this post request is going to post the data to our URL, products, and then, for example, 001. But for now, we know the endpoint is going to be our URL, products, and then a product ID, and then we can strip it off and look for that in our database. So if there is no product ID, which will be pretty strange, we're going to return status code 400, and the body is going to be json.stringify missing path param. After that, let's scroll down, let's make some more space. So we'll do a try catch. We do const db response. We're going to await DynamoDB .send. What are we sending? We're going to do a new get command. So we're not scanning and we're not doing a query. We're doing a direct get because we know the ID beforehand. We also need the table name like last time, but also the key, which we're going to set up in a minute. The key for this item is going to be product ID with the product ID. So shortly you'll see why we use this. We're going to set up a DynamoDB table, and we're going to have the key for each item is going to be a product ID, for example 001. But first we need to actually tell it which table to query. So again, we're going to do const product table name, and that is going to come from process.env.product table. So we take that and pass it into our get command, so it knows exactly where to look for it. It knows exactly which item to look for, and that should be extremely quick. Now on that DB response, if there is a DB response and it has an item, I'm going to return status code 200. And on the body, we're going to JSON stringify DB response .item. We run the get command, we get back a response, and that will have an item on it. If there is an item, we're going to respond 200 and stringify that particular item because we found it. Else, we're going to return status code 404. And on the body, JSON stringify, we're going to have a message, and that's going to be item does not exist. If there are errors, we're going to return status code on the body, JSON stringify, error. Let's tidy this up. Okay, so we're trying to get a response from the DynamoDB. We're sending a get command because we know the ID of the item we want, and we know what table it belongs to. If there is an item, respond 200 with that item stringified. If it's not found, return not found or does not exist. Any errors, return that as well. So I think this handler should be good to go. I think the next step is we should probably create our DynamoDB table so that we have something to pass into this handler with that table name. So let's go and do that. Inside constructs, I'm going to create a new file. I'm going to call this simple database stack.js. Close these down. Now inside here, we're going to have simple database stack, and that is going to extend stack, and the stack comes from CDK lib. From there, we're going to have our constructor, taking the scope, which is always scope for me, the ID and the props. Then we're going to call super with the same scope it is, props, there we go. Now from here, we want to create our new table. So I think we called it product table, and that is going to be new table, which we need from AWS DynamoDB. Going to take in this and we're going to call it product table. Now we need to create a partition key, and that will be, in this example, the product ID. So whenever we do a get command or a query command, we have that specific ID and we can index into the database and get that data extremely quickly. So partition key is going to be called product ID. And the type of this partition key is going to be attribute type, I think from AWS DynamoDB. Okay. And then we've got string. So we're going to use strings for our partition keys. Now we have to have a billing mode. And for this example from AWS DynamoDB is going to be pay per request. And this one, deletion protection. When we run CDK destroy, when I was getting started, I noticed that my databases never got deleted. So I had a bunch of destroyed projects that didn't exist anymore, but I had tons and tons of DynamoDB tables that were not deleted. Now, to be able to pass the table name to our Lambda functions, we need to add it to this class. So we're going to do this.product table equal to product table. So now whenever we use simple database stack, the class, we can now get access to this variable. Okay. So now we're going to do module exports, and that is going to be simple database stack. Okay, I think the next step is going to be to create our API stack and start putting things together. So we're in our constructs, we're going to do simple API stack.js. We're going to create our class simple API stack, and that is going to extend stack from CDK lib. Again, we're going to have the constructor, and that's going to take in scope, ID, and props. Then we are going to call super again, not scooper, scope, always scope, ID, props. Now, first thing we're going to do again is const API. We're going to create our new REST API. And that is going to take this, and we're going to name it simple REST API with DB. First thing we're going to do is pull in our two lambdas, get one and get all. So first, get one product. That's going to be a new function, which is going to come from AWS Lambda. It's going to take in this, and we're going to name it get one product function. Again, we need to have a runtime. So that runtime is going to come from AWS Lambda again, and the runtime is going to be node 18. Then we have to have our handler where the code lives, and that is in products get one.js, but we're not going to have JS. We're going to have get one.handler. And then where does all of that code live? We're going to pull in code from AWS Lambda, and we're going to do from asset, so src -lambdas. Now, to be able to have access to our DynamoDB table from this Lambda function, we have to pass in the actual table name, and that's going to be as an environment variable. We're going to have, I think we called it product table in all caps. So product table, all caps, and this is going to come from props, product table, and then table name. So you'll see in a minute how we get access to this. We have our database stack, which exports that product table, and we have our REST API that imports the product table, and it passes in specifically the table name. In a minute, we'll see how we can actually communicate between our database and our REST API and pass this variable between them. Next thing we're going to do is our get all products. So const get all products. That's going to be a new function. It's going to take this, and we're going to do get all products function. Close down that, make some more space. Runtime again is going to be runtime node 18. The handler I believe it lives in the same place. We have products, get all, I believe, dot handler. And in the code, where does all this live? We're going to do code from asset, source folder, and then lambdas again. And we also need to have access to the database table name, so we can just copy this environment variable and paste that in down there. We have our two lambdas. We have our database environment variable, but we need to give these two lambdas the permission to actually read data from that table. We're going to do props.product table, and we're going to grant read data. And we're going to say that get one product is allowed to read the data from that table. We're going to do the same thing again, but this time get all products. So both of our Lambda functions are allowed to read data from our product table. And in a minute, it's going to be passed in via props. Okay. So now we do our integrations. We've got get one product integration. And that's going to be a new Lambda integration, get one. We can do the same thing again with get all products integration, new Lambda integration, and then get all products. So we have our integrations. Now that we have our integrations, we can add some resources to our REST API path. So I want my domain, products. I also want to get a single item based on its ID. So that should be product ID. So let's start with the first one. We're going to have products. That is going to be on the API root. And we're going to do add resource. And we want to add products. Now on that, we want to add a method. So for this one, we want to get all the products. So that would be get all products integration. Okay, so that should be the first path set up. So the next one, we want to add a new resource on top of products. So let's do that. So we need const single product. And that is going to be on top of products dot add resource. And we're going to have curly braces product ID. So now on single product, we're going to add a method. It will be a get request for a single item. And then that will be get one product integration. And I believe that is all we need to get going. We've granted read access to our table. We've created our integrations. We've created our products resource for get all products. We've created our single ID resource, get request for get one product integration. Okay, so module.exports equals, what did I call this? Simple API stack. Perfect. Okay, so now we have our database stack and our API stack. We need to find a way to get these two to communicate with each other, and that will be inside of our main.js. So inside of main.js, we're going to have const CDK, and that is require AWS CDK lib. We're going to create a new app. That's going to be new cdk.app. Now we need to pull in our database. So we're going to have const db stack. And that's going to be new simple database stack. Yep. Pass in the app as the scope. And we're going to call this simple REST API database stack. Perfect naming. And give it a ID number and no props. Now for the API stack, we're going to do new simple API stack from our construct folder. We're going to pass in app. I'm going to name it simple REST API stack 003. And this time we are going to have some props. Okay, so we exported the product table from our database stack, and we can now get access to it and pass it into our API stack, which then can get passed down to our lambdas. So we're going to have product table, and that is going to come from db stack.product table. There we go. You see how we exported it and it becomes available in IntelliSense. So now we've passed that down into Simple API Stack as a prop. So if we go back into API Stack, we can see props, product table, and table name. From here, we should be good to go. We can do CDK deploy all. And when it asks if you want to create the changes, just hit yes. Okay, once I ran CDK deploy, I went back to check some of my code and I realized that I've made a small mistake. If we look at our get1 lambda function, we see the get command is coming from AWS CDK lib DynamoDB. If we look at our scan command, we're importing it from the incorrect package. And that is going to cause some issues with your JSON when it gets returned from the lambda function. It's going to look like DynamoDB's custom syntax, but we want regular JSON. So we're going to cut this out of here and paste it just down here. So scan command should come from AWS CDK lib DynamoDB, not from the client. So when it comes from lib DynamoDB, it automatically unmarshals the JSON into the JSON that you would expect to see, not DynamoDB's custom format. So now that we've changed that, we can deploy our code again. So we're going to run CDK deploy all. Okay, so now we have our URL. I've got to hang on to that for a second. Don't close down the terminal. Right now, we're going to go back over to the AWS console and we're going to add some items to our database. Right, so we're in the AWS console. We're going to search for DynamoDB. We're going to hit explore items and then we're going to go to the table that we just deployed, which is the products table on the simple RestApi database stack. And then I'm going to click on create item. From here, you can see we've already got our partition key, which is product ID. That's empty. I'm going to click on JSON view. We're going to turn off the DynamoDB syntax version. This is what I was talking about. That's why we had to change where the scan commands came from, because when we get the JSON like this, we have to unmarshal it and do a bunch of stuff. We want just standard JSON. So we're going to add our blue jumper, one of our items, into this section. Notice that product ID is on the same level as the rest of the object items, but DynamoDB uses this particular key as the partition key. So we're going to hit create item, and that gives us one item. We're going to do that again. Create item, JSON view, turn off the custom syntax, and update the product ID, change this to red jumper, what was it, 1999, and then size small. Create item. So now we have two items in our database, item 001, 002, blue jumper and red jumper. Now if we head back over to our code, we should be able to hit one of our endpoints and get these two items back. So if we grab the URL that was output in the terminal, I'm then going to head over to my Thunder client. I'm going to create a new request. We'll just update the last one. And the endpoint was products. So we're going to close down the terminal and see if we can get all of our products from our REST API. Okay, there we go. We have our list of products. We have two items, blue jumper and red jumper. And you can see it's coming back as an array of items, exactly as we expected. Now let's try and get a single item. Let's get 002. I believe it was just a / and then the item number. Let's see, was it a GET request? It was. So we should just get one item back. And there we go, the red jumper, product ID 002. And that's it. You've seen how to create the lambdas, add them to your REST API, give them both access to be able to read data from your DynamoDB table, and then set up the correct paths on the API route to be able to get all of the items or to get a single item. You know how to create a DynamoDB table. We've gone through the partition key, the billing mode, and we've exported the table name so we can share it with other resources in CDK. If we head over to main, we can see that we've imported our DynamoDB stack, and from that we can get the table name and pass it down to all of our lambdas in our REST API. Okay, thank you for watching that video. Now you know how to deploy a REST API, Lambda functions, DynamoDB tables. You're pretty much fully equipped to start designing and building your own serverless applications at a very simple, functional level. So if you want to learn how to connect and deploy and build with the AWS CDK, like and subscribe, and I'll see you in the next video.